notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, these first three sections here, sections 1, 2, and 3, all 51 videos have been completed and published in their entirety on YouTube. Section 4, measurement, all 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics, all 18 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 6, algebra. This is the 15th of 22 videos, and hopefully later in this month, September 2025, I should finish this section. After that, section 7, relations, functions, and graphs, by October 2025, to be followed by section 8, geometry and trigonometry, in November. And finally, section 9, vectors and matrices, to be completed by the end of December of this year, 2025. Disclaimer down here, this schedule is just a projection and is not to be interpreted as a contract with anybody. I will eliminate most of the typical introduction in this video so it wouldn't run too long. This video is quite involved, so I'll skip that and that. Okay, overview, continued. This page on the left here, we have completed objectives 12 to 14. That is up to here. Notice that objective 14 was divided into 2 videos. So while we are now at objective 15, we are actually at video 16. Now, please note the next objective, objective 16, deals with solve quadratic equations algebraically. And I will mention a few things about that in this video before we go on. And then, of course, we have the rest of this section, section 6, algebra, which will be completed in these last 5 videos here. So as I said, we finished up to objective 14 in 2 videos. So that took us up to video 15. Out of those, these indicated in yellow have been published on YouTube in their entirety. The others are only partially published. I am now at objective 15, video 16. Once this video is finished, it will only be partially published. So as I said, objective 15, which says rewrite a quadratic expression in the form of a times x plus h squared plus k. Sometimes you hear that being expressed as completing the square. So rewrite a quadratic expression in this form, as we said just now, and that means to complete the square. So what is a quadratic expression? I explained that in the last video, so I'll briefly mention that again. A quadratic expression is any expression in which the highest power of a variable is 2. For example, ax squared plus bx plus c, the highest power is 2. And they generally have this format, ax squared plus bx plus c. That's a quadratic expression. Now, if you look down here, you will notice that this one here has a square, it has an a b, it also has a c, but c is not necessary and b is not necessary. So that is a quadratic expression. This is also a quadratic expression because of that 2 there. It doesn't have any b. And so is this one because of that 2 there. It doesn't have any c over here. So those 3 are all quadratic expressions. This one down here, 5x minus 8, it is not a quadratic expression since its highest power is not 2. Its highest power is 1, 5x to the first power. So this objective requires that this format here be rewritten in this other format down here, completing the square of a quadratic expression. So what does completing the square of a quadratic expression mean? Before we get to that, what are factorization and completing the square leading to? Why do we need to know these things? Recall in the last video, we learned how to factorize algebraic expressions, like this one, for example. We can factorize to that. Well, an algebraic expression can easily be converted into an algebraic equation by simply adding equals 0 on its right. So that expression with an equal to 0 now becomes an algebraic equation. One method of solving this particular equation that you see up there is to factorize it. And once you factorize it and you get these two factors equal to 0, then either one could be 0. So you set either one as 0 and you work it out and you get that x could be -1 or +4. But more of this in the next objective. There are many quadratic algebraic expressions in such equations that cannot be factorized. Example, 2x squared minus 5x minus 8. So the very next best thing is completing the square is the next stage when factorization cannot work. So what are we doing here? It simply means to rewrite this part of that expression in a squared format, and then you have to make adjustments to accommodate for this c, and the adjustment is called k. So that's what we are doing. We are rewriting this part in a perfect square, making adjustment to the c so that the equation still holds true. Recall that when we factorize a squared plus 2ab plus b squared, we get a plus b squared. That is called a perfect squared. Well, this is somewhat similar to that, but a little more complicated. We will consider the general principles first. But before we get to that, a little review and preview. Solving quadratic equations is a very important part of algebra. Very important. An algebraic expression can easily be converted into an algebraic equation by simply adding equals 0 on its right, as I said in the previous slide. So we get that. One method of solving that equation we see up there is to factorize it, and we get the solution as being -1 or +4. That's one method. But there are many quadratic algebraic expressions in such equations that cannot be factorized, as I mentioned not so long ago, like this one. When that happens, completing the square is the next stage when factorization cannot work. So this is the second method of solving a quadratic equation. Now, a third method to solve a quadratic equation is the use of a formula, and this formula is actually given in the list of formulae that you will get for your examination. It looks like this. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So you look at those are three methods of solving a quadratic equation. Those are three methods of solving a quadratic equation. Whether it can be factorized or not, you will decide which one to use. Even if it can be factorized, and even if you can complete the square easily, you may still choose to use this third method because it may actually be easier, for one, and secondly, this formula is given on the examination formula sheet. So by the way, there is a fourth method that can be used to solve quadratic equations, and that is making use of graphs. But that is not included in this objective. So that's four ways you can solve a quadratic equation. We will take a brief look at this last method before returning to this objective. So remember that quadratic equation we had just now. We solved it and we got -1 or +4. If we set it up like this, y is equal to that quadratic equation. We get some values for y. We get the corresponding values for x, and we plot a graph. This is what the graph looks like. Now, if y is equal to 2x squared minus 6x minus 8, and we consider y at the 0 position on this graph, which is down here, then in essence, y becomes 0, or that equation now becomes 2x squared minus 6x minus 8 is equal to 0. But we are only considering when y is 0. Now, if y is 0 here, you go across this x line, what do we get? We find that x is actually -1 at this point, and that x is actually +4 at this point. So we can solve that quadratic equation using a graph, -1 and +4. Okay, that was just in passing. Let's get back to this objective. So this is a general format. So first of all, we will group the variables. So the variable is x, so we group that part there. ax squared plus bx, and then of course you have a plus c. We will factor out a from there. So now we have a on the outside, but if we take out a from there, you cannot leave that b there, because when you multiply a by b, you will get ab. So we have to put an a under that b. Now, this is the same as that up there. So that's the second thing we will do. Thirdly, to make a perfect square in the brackets, we will add the square of 1/2 of the coefficient of x. So this is the coefficient of x. We will add the square of 1/2 of that. So we rewrite it like this. And in this bracket here, we will add the square of 1/2 of that. So that would be b over a, and half of that will be b over 2a. Okay, that's the third thing we will do. Fourthly, we will subtract that last term in the perfect square, including a, at the far left, from c. Okay, this last term here, including the square, this term here, including that a there, we will subtract from this c. So c minus this term here multiplied by a, because we cannot drop that a. All right, we're almost finished with this. That's the fourth step. And finally, we will rewrite the square bracket as a perfect square and simplify the term on the far right. So this square bracket here, the square bracket here in green, excluding that a, we will rewrite this as a perfect square, and then we will simplify this part over here. So the perfect square in here is x plus b over 2a, x plus b over 2a, everything squared, not forgetting that a in front there. And then we simplify this. So let's get this quite clear. This is the completing the square. So let's simplify all of this over here. To do that, of course, we have to combine the last two terms on the right of c. So we combine the last two terms on the right from c. So we have to combine that. Combine this, and we get 4ac minus b squared over 4a. And that's it. Ax squared plus bx plus c is now in the format of a times x plus h squared plus k. So this here is what we were heading for. That is what we had to do. That there is k, and this here is h. K and h. So don't let the looks of this stress you out. It is not as difficult as it seems. Besides, you don't need to know how that final expression is derived. All you need to know is how to use it, this expression down here. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. So example 1, we want to express that quadratic expression in this format. And we will use this formula that we just derived to do that. Now, this is one approach. You can learn this formula and use it anytime you have to do this. It is not given on the formula sheet during exam. So, but we just derived that formula. We will use it like 5 or 6 times, and then we will go back to using the various steps. So that is the formula we just substituted. Now, this is fairly easy. A here is 1. That's A. X is there. B is this expression here, plus 6, over 2a. Well, we already said a is 1. So 2a squared plus 4ac. We know a is 1 and c is 5, the last term here. So 4ac will be 4 times 1 times 5 minus b squared, and we said that b is 6. So that would be minus 6 squared over 4a. That would be 4 times 1. Now, once you have that, you simplify this expression. So 1 times x plus 3, 2 1s, 2 3s, squared, and this part over here works out to be negative 4. That is to say, this part here is 20 minus 36 over 4 1s 4. This is negative 4. So now you don't need to write that 1. So what you have is x plus 3 squared minus 4. That is what we were aiming for. Remember, a is 1, but you don't need to write it. So you now have this expression on the left here in that format, this format here. That's our answer. We can expand the answer just to check to see if it is correct. X plus 3 squared, which is x plus 3 multiplied by x plus 3. And then, of course, you have the minus 4 there. If we expand that, will we get back this expression we started with? So we expand that, and we get x squared plus 6x plus 9 minus 4. We will simplify that part there. And so we have x squared plus 6x plus 5. Was that what we began with? Yes. So now we are able to express that quadratic expression in this format, which is this over here. And by the way, that quadratic expression can be factorized. So if you have that in an equation, you could use completing the square as we just did, or you could factorize and get the same answer.